Okay, so my dear student, let us continue with our interesting concept of color resistor color code. Students, say resistor color code. Say resistor color code. So as we learned that the resistor color code, it's a way that help us to find what? To find resistance of the resistor, to find tolerance of the resistor, and also it can be used to find temperature coefficient of the resistor. So we've been covering about the concept of what? The concepts of tolerance, which after that it's a little bit, it's enough. We'll discuss a little bit the concepts of the temperature coefficient after when we'll be learning about the 5 color bands. We are going to discuss about temperature coefficient after discussing about the 6E band or 6E band of resistor. So if that's the case and everything is clear, let us move. And this is what you have to move for. So we have resistor bands. So let me teach you about the concept of resistor bands. Resistor bands. Class, say resistor bands. Say resistor bands. We say that fixed resistors have color band. Fixed resistors have color bands to inform a user, about their built-in properties. Built-in what? Properties. So fixed resistor, say fixed resistor, which you call them fixed linear resistors, have color bands. Say color bands. Say color bands. So the band, when you say that the bands is actually an arrangement of colors. Have color bands to inform a user about their built-in what? Properties. We say that each band adds one piece of the information, adds one piece of one piece of information, one piece of information to the whole picture. To the wall picture, depending on its position, and its color. And its color. Separating each band. Say each band. Say each band. Each band located in any fixed linear resistor adds one piece of the information to the whole picture depending on its position and its color. Separating. We say that we have bands. Any resistor, any fixed linear resistor has at least more than 3 bands. 3 what? Bands, right? And then we say that, but each band among those 3 bands adds what? One piece of the information to the whole picture of the fixed linear resistor depending on its what? Position and its color. So the information which will be added by any band of the resistor depending on what? The position, where is it located, and also depending on what? Its color. Are we together, class? Are we together? Pencil into sorted scalar. So he said that in electronics and electrical engineering and science, there are three major color bands. Major color bands. There are three major color bands of the fixed linear resistors. And this we name them as follows. There are three major color bands. How many color bands do you, how many major color bands do you have? Students, I'm talking to you. How many major color bands that you have in on the fixed linear resistor? We have three major color bands. There are three major color bands of the fixed linear resistor. And the first one, we call it 4 color band resistor. And also the second band, it's 5 color band resistor. And the third, it's 6 color band resistor. Sometimes this one, we just call it in electronics in short 4 bands. And this one in short, we just call it in electronics 5 bands. And this one in short in electronics, we just call it 6 bands. So let us discuss each of the 3 color bands, and then we'll see how we use them. So let us start with shorty 4 color. Class, say 4 color band. Again, say 4 color band. All online students and offline students, say 4 color band. And then so you have 5 color band. Say 5 color band. Or 5 bands. So 5 resistor bands. And the 6 color band. So 4 color bands, plural. So let us discuss 4 color. Four color bands of fixed linear resistor. First, we say that the 4 color bands or 4 bands of the fixed the 4 color bands is the most common. Is the most common type or most common band of different fixed or linear fixed resistor. Should we call them linear fixed resistor or fixed linear resistor? Fixed linear resistor. Eh? Are you sure? Fixed linear resistor or linear fixed resistor? Fixed linear resistor. Eh? Okay. So this is common. This is common. Is the most common band of different fixed linear resistor. So here we have 4 color bands. So separating the first, so separating. So now I'm explaining those bands. So it means that let me just draw. You can find that this might be the shape. Suppose that this is the physical appearance of the fixed linear resistor. So here it's terminal 1, here it's terminal 2. Remember that resistor does not have polarity. Say resistor does not have polarity. So it does not have positive and negative as capacitor, as an electrolytic capacitor. So listen, so this is the linear. It can be either metal, film, fixed linear resistor, or it can be some other types of resistors. So look. So here we can have the first band. The first band. Then here we can have the second band. The second band. And this one we can have the third band. And this one we can have the fourth band. So first, second, third, fourth. Okay? Hi. Figure 1. The 4 bands of fixed linear resistor. So separating. So this is the first, second, third. So first, second, third, fourth. Separating, look on the blackboard. The first band and second band represents or indicate the significant digit. Stop writing, I say. The first and the second, or simply say that the first 2 bands. Or you can say that first the first and second bands, the first and second bands indicate the significant digits. Significant digits. Say significant digits. Say significant digits. So I will teach you what it means of the significant digits. So the first band and second band represent what, or indicate what? Significant what? So it means we are going to have 2 significant digits. The first significant digit is this one. And the second significant digit is this one. That's why we've used the letter S, because this is plural. More than one what? Significant digit. Are we together? Then we say that the third color band The 3D color band indicates what? Indicates the multiplier. Indicate what? The multiplier. Say the multiplier. Let me just write this one in capital letter. The multiplier. So the 3D color band indicates the what? Say multiplier. Say multiplier. Eh? So the 3D color bands indicates the multiplier. So it remains what? The fourth. The fourth what? Color band. Where is the first color band? This one. So the first color band indicates the tolerance. Indicates what? Indicates the tolerance. Say tolerance. Say tolerance. So you see that how can you know the tolerance of the resistor? You have to know how can you interpret the color bands. If you don't know how to interpret it is difficult for you to know tolerance of 40 of the resistor. Are we together? Yeah. Do you have any question at that time? Do you have any question about what you've covered? In case you have any question, don't hesitate to raise up your hand for the physical student. And for the online students, don't hesitate to ask in the comment section of this video that you're watching right now. So when you say that a resistor of the 4 bands, look, Ruben, but Ruben, it's, stop. Okay, my dear student, after teaching you about the 4 color bands of a resistor, now it's a time for me to do simple demonstration. We'll do just a practical of this one and how can you use these color codes in order to compute the resistance of the resistor. But right now, let me just demonstrate. These are the fixed linear resistors, and they have different values, but also they have different physical size, but also they have different resistance, and also they have different power rating. This is 1 watt, this is 2 watt, this is 3 watt. So you can see that this is 4 bands. First band, second band, third band, fourth band. Also this one, this resistor has 4 bands. First band, second band, third band, fourth band. Then first band, second band, third band, and the fourth band. So this is the examples of 4 band fixed linear resistors. And we say that in electronics, these are the commonly used resistors. But also 5 bands is common, right? So this is the demonstration. But another question comes in your mind, and comes also in my mind. Well, teacher, I've seen the color bands, the 4 color bands resistors. But now I have a question. Where are we going to use them in electronics? The answer of that question might be found in this amplifier. This is the power amplifier circuit. So in this power amplifier circuit, if just put in this way, it will be easier for you to visualize it. In this power amplifier circuit, there's a number of discrete components. But among those discrete components are resistors. So all of these, the resistor, all of these are resistors. But you can examine the color bands. The color bands of this resistor is 4. First band, second band, third band, fourth band. Similarly, here first band, second band, third band, fourth band. Similarly here, first band, second band, third band, fourth band. But these blue resistors, they don't have 4 color bands. How many are they? First color band, second, third, fourth, fifth. So I'll be using these to demonstrate where are we using the 5 color bands resistors in electronics. Are we together? So if you also examine, this is a 4 color bands resistor, first, second, third, fourth. Also you have some small resistors. For instance, this one, it has 1, 2, 3, 4, 5. 5 color bands. This also is 5 color band. 1, 2, 3, 4, 5. 5 color bands. Similar, this is 5 color bands. Are we together? So, because the next part, the next concept that I'm going to teach you is about 5 color bands. So, and then I'll demonstrate to you. So, I think that you have seen the 4 color band resistor. So, the first band represents what? First digit, significant digit. The second band represents what? The second significant digits. The third band represents what? Multiplier, right? And then the fourth band represents what? Or indicates what? Tolerance. If there is any question about the 4 color bands, you may ask. But if there is no any question, let us continue. Number 2, the second major color bands. 5. Tell your neighbor now we are in 5 color bands. Say 5 color bands. Say 5 color bands. Say 5 color bands. Say 5 color bands. Eh? Eh? So the 5 color band, the 5 color band is similar. The 5 color band is similar to the 4 color bands of what? 4 color bands of a fixed linear resistor. Fixed linear resistor, except that it has 3 bands. It has 3 bands. It has 3 bands indicate 4, indicates 3 bands, indicate 4 significant digits. Significant digits. So the 5 color band resistor is similar to the 4 color bands of a fixed resistor, 4 color bands of a fixed resistor, except that it has 3 bands indicate for significant digits. Remember, for the 4 bands, it has how many bands to indicate significant digits? 2. First and second. These are the 2 bands that indicate what? Indicate what? Significant digits. For the 5 bands, the first 3 bands indicate significant what? Digits. Right? And then the second, the fourth color band the first color band, indicate, or 5 bands, indicates the first color bands indicate the multiplier. Indicate what? Multiplier. Say multiplier. I will teach you and I will clarify what the means of multiplier later. So the fifth band, this one indicates what? Indicates the resistance, resistor what class? Tolerance. Resistor tolerance. Resistor tolerance. Are we together? Resistor what? Separating. Look on the blackboard. So let us draw the physical appearance of the 5 band. Remember that in definition of resistor, we define that a resistor is what? 2 terminal. Later on, I will teach you about resistor pack. Say resistor pack. Resistor pack, it's a component which contains more than 1 resistor. But remember, even in resistor pack, resistors still have 2 terminals. So this is our resistor, terminal 1, terminal 2. Suppose that this is the first color band, this is the second color band, this is the third color band, this is the fourth color band, this is the fifth color band. Are we together? So this is first, this is second, this is third, this is fourth, this is fifth. Separating. Tell me which shows. Remember that for this one, we say that this one, these 2 bands shows what? Significant what? Significant digits. Right? And then this one shows what? Multiply. And this one shows what? Tolerance. Are we together? Separating. So for this case, the first one, this one and this one and this one, these 3 first bands represent what? Significant what? Digits. Right? The first color bands represent what? Multiplier. This one. And this one represent what? Tolerance. So this will be figure 2. The 5 color band resistor. If you have any question about color bands or about the 5 color bands, you may ask. In electronics, we might also have 3 color bands. It's not common. So listen, so it's time for demonstration. Let me demonstrate. Okay, now after teaching you the concepts of the 5 color bands, now I'm going to demonstrate to you how do they look like. This is quarter watt linear fixed resistor. And all of these resistors, each resistor, it has resistance of 22 ohm. That's why it has been written 22 ara. Ara stands for ohms. Then, if you examine all of these resistors, they have 5 color bands. First, second, third, fourth, fifth. So I can just bring back to the lens. Means bring closer and closer. Have you seen it? Fine. Is it okay? Huh? Okay. So these are the 5 color bands. Then comes another question. Where are we using it in electronics? That's good. We have a working amplifier circuit here. So in this working amplifier, we've mentioned in previous demonstration that these are the 4-color bands resistors which have been used here to perform different functions of the resistor. Remember, resistor does not only limit current. Resistor has more than 10 functions, right? So this is 5-color band. 5-color bands resistor. 1, 2, 3, 4, 5. Similarly, this one is 5-color band. 1, 2, 3, 4, 5. This one is 5-color band. 1, 2, 3, 4, 5. 5-color band. 1, 2, 3, 4, 5. 5-color band. 1, 2, 3, 4, 5. Low power, quarter watt. 1, 2, 3, 4, 5. Are we together? So it means that within a single electronic circuit, you can find that the designer has used the 4-color bands resistors and the 5-color band SOTI for the particular reason. Are we together? Is it clear, student? Well, so if it's clear, let us continue and learn about 60-color bands. 60-color band. So this is number 3. 60-color band. 60-color bands. Say 60-color bands. Say 6-color bands. Say 60-color band. But before I teach you these 60-color bands, I want to tell you that the 4 and the 5 color bands resistors are often used in electronics engineering to design circuits. So these are the often used 4-color bands and the 5-color bands. So ladies and gentlemen, let me teach you about the 30-color band, which is 6-color band. 6-color bands. Okay, we call it 6 bands. Class A 6-color bands. So 6-color bands resistor. But especially with our main focus is fixed the resistor. In intermediate programs, I will teach you about 20 variable resistor, where we are going to learn about potentiometer and the trimmer. In advanced practical electronics engineering, I will teach you about the surface mounting device resistor, or SMDOT resistance. And also, in that advanced, I will also teach you about the non-linear resistors, such as photodiode, varistor, semester, the other one, microcontroller. So the 60-color band introduces an entirely new band. So this is just the 6-color bands is actually kind of the new band. So he said the first the first three bands, the first three color bands of the 60 color bands indicate significant. Significant what? Digits. This is not the first. Listen. The first three. Let me just write. The first three color bands. So what do you mean? It means the first, second, and third. Then we say the fourth color band indicates multiplier. Indicates what? Multiplier. Say multiplier. Say multiplier. Say multiplier. Good. Then we say that the 50 color band indicate the fifth color band indicate what? Tolerance of the resistor. Then the 60 color band indicate what? Temperature temperature coefficient. So that's why we say that resistor color band can be used to determine, stop writing. So from this fact, you can notice that when we define the meaning of what? The meaning of resistor color coding, we say that resistor color coding, it's a way to find what? Resistance, tolerance, and the temperature coefficient of what? Of a resistor. Just to go back to the definition of tolerance. Resistor tolerance. Go back, refer. Because you have forgotten. Resistor tolerance. What is it? No, not resistor tolerance. Excuse me. Go back to the definitions of resistor color coding. Read it. Is a way. To find what? Resistance of the resistor. Tolerance, which is not the most insisted concept. And what? Temperature coefficient. So the temperature coefficient can only be found in a resistor which has a 60 band color coding. Can I repeat? Listen. The 4 color band and 5 color band, and 6 color band can help you to find resistance of the resistor. Right? Also the 4 color band, actually you're not listening, and the 5th color band or 5 color band and 6 color band can help you to find what? Tolerance of the resistor. Are you together? But the 4 color band of resistor and the 3 color band and the 5 color bands of resistor cannot help you to compute the temperature coefficient of the resistor. Why? Because there is no any band that shows the temperature coefficient. So the 6 color band resistor, it's a one that gives you the information by using the knowledge of color that can help you to compute the temperature. What? So it means that in case that you have a circuit where you need a resistor, which actually that you need also to know its temperature coefficient, then you have to go and you have to find a resistor of the 6 color band. Is it clear or it's not clear? Huh? It's clear? Oh, wonderful. Congratulations. So this is our linear fixed resistor, terminal 2, terminal 1. First caliber, second caliber, third caliber, fourth caliber, fifth caliber, sixth caliber. So look, this is first, this is second, this is third, this is fourth, this is fifth, this is sixth. The first three shows what? The first three shows what? Significant what? Significant digit. So this is, I just write in a short, significant what? Digit. And this one shows what? Multiplier. This one shows what? Tolerance. This one shows what? Temperature what? Temperature coefficient. So this is figure what? Figure 3. The 60 color band of fixed what? Resistor. So if that is clear, so one thing that you cannot, so the one point that I told you that to note means that we say the 60 color band, the 6 color band, the 60 color band resistor indicates what? Temperature coefficient. So this, it's the only resistor that you can use the color band to compute temperature coefficient. Are we together? Yeah. So if everything, so I think that, did you understand the concepts of the color band? Have you understood? Good. If you have understood, now let me just take you into the concept of 40 of resistor, resistor color, digit, resistor color band, so resistor color band, where we are going to define them in terms of color, plus significant digit, plus tolerance, that is So what does it mean? Listen. So we are going to list, we say that in electronics, basically we have 9 colors. We have 10 colors that have been used often in resistor color band. Do you listen what am I saying? In electronics, we have 10 colors. So before just give you these values, let me just see. So you say that in electronics and electrical engineering, there are 10 colors that are used to indicate significant digits and the multiplier of a fixed linear resistor. So we've been discussing about color band. So now let us go into too much details. So in the too much details, we say that we have how many colors? 10 common colors. When you go and read different books and different or advanced, just different articles or journals, you might find more than 10 colors. But these 10 colors are common. And along your journey of learning electronics engineering, telecommunication engineering, electrical engineering, you will encounter them. So it means that these 10 colors, they are used to represent duty, they are used to indicate significant digits and duty multiplier. Stop writing. I will mention them in terms of the number. So the first one is black. So let me just mention them in this system. Here, I will mention the color. And here, I will mention the digit value, the digits that you are using for that color. Stop writing. I'm going to mention all the 10 colors, but also I'm going to mention the corresponding digit for that color, right? And then the next column, I'm going to mention the multiplier. If that color, the multiplier, the value of multiplier. But also the other column, I will mention the tolerance. If that color has been used to show tolerance. Stop writing, I say stop writing, look and listen. I say stop writing, put your pen and your pencil, put it apart, away. Because this is very important information. I will mention the color, right? I will give you the value for that color if it has been used on the resistor. I will show you the multiplier, the value of that color, if it will be used as a multiplier in the third band, or in the first band, or in the sixth band. Right? Because the multiplier, if you have analyzed it, it can be used in the what? Third band or fourth band. Right? So what if that color will be used in the section or in the positions of multiplier? What will be its value? Then I will show you if that color will be used as a tolerance. Will be used in the part of 40, in the positions of 40, tolerance. Are we together? The first color, then I will teach you the trick. How can you remember these colors? Easily. So the first one, the first color, it's a color that we call it black. Black like Olenjolai. So the value of the black, if it can be used in significant digit, the value of black is 0. Right? And the value of black, if it will be used, the black color, if it will be used in multiplier, it will be 10 power 0, which is equal to 1. Then the tolerance of the black is not mentioned. Black cannot be used to show the tolerance of the resistor. The second color is brown. Say brown. So brown, its significant digit is 10. Then, when it will be used its significant digit is 1. When it will be used in multiplier, it will be 10 power 1. You increment this 0 by 1. You increment the exponent by 1. So 10 power 1 is equal to 10. If the black color, the brown color will be used as a tolerance, this will have the tolerance of 1%. 1%. So if you see 1%, you know that the variations of that resistor is small. It has a very small variation. Why? Because its tolerance is small. Right? Are we together? Are we together? Then the next color is ready. Who is ready? Is Ruben ready? The value of the digit is 2. The value of multiplier is 10 power 2. And this makes 100. If this ready color will be used as a tolerance, its tolerance value is 2%. Then the next color, look your neighbor. Your neighbor is writing now because she or he said, I have understood. Those are the Bongo people. Orange. The next color is what? Class, say black. Say black. Class, say black. Class, say black. Brown. Red. Orange. The value of significant digit for orange is 3. And then here, if it will be used as multiplied, it will be 10 power 3, which is equal to 1,000. Then the orange might not be used here as the color for the tolerance. Do you see, Jack? Yes, I said some of the students, Bongo. Yellow. The next color is what? Yellow. The value of its significant digit is what? 4. Then if it be as multiplier, 10 power what? Power 4. Right? This is equal to what? 10,000. Yellow cannot be used as a tolerance, as a color for the tolerance. Then the next color is what? Green. Say green. So the significant digit for green is 5. Then, if it be used as multiplier, it will be 10 power 5, which is equal to what? 100. What if you get 100,000 now in your pocket? Will you enjoy the life? This one also cannot be used. The green color, this is green, eh? Yes, if green will be used to show tolerance, then tolerance value is plus or minus 0.5%. Are we together? Eh? For you, you have to make a table. You have to make a very nice table because you say engineering is all about what? Numbers. And it's all about what? Diagrams. It's all about what? Formulas and mathematics and what? And equation. It's all about what? Tables. It's all about what? Graphs. So you must love what? You must love all of those information about what? All of this information about engineering. Engineering is beautiful. So you'll make a table. Then here, can you make another line? I know that you are good in making tables. But let me make, because students will say that even the teacher did not make a table. Now we are going for the next color. That will be the seventh color. The seventh color is blue. Students say blue. Say blue. Are you blue? Ask your neighbor, are you blue? Significant digit is number 6. Then if it has been used, it is 10 power 6. and this is 1 million. Ask your neighbor, what if you have 1 million in your pocket? Would you come to learn the program of fundamental of practical electronics engineering, or you could go and enjoy life? You could go and enjoy life, eh? Okay. Then the seventh color is violet. So I know ladies are very good in this concept because they are very good in color. Women are excellent in color rather than men. Right? And that's why you find always in the hairdressing, they always match. But for men, we don't care. We don't care about color. We just care about the dress, then life goes. So violet is significant digit is 7. This is 10 power 7. And this is 10 million. This is a lot of money if you could have it in your pocket. Ruben now is writing. If it be used as the tolerance, it's plus or minus 0.20, 0.1%. Hello? The next color is gray. Say gray. Show your neighbor the gray color, because you have to learn now color. Show your neighbor the gray color. So the significant digits for the gray is number 8. Then if you use it, is 10 power 8. And this one is equal to what? 100. No. Gray. No. I made a mistake. Violet cannot be used as multiplier. That's the beauty of electronics. You have to learn with steps. These are the colors: black, brown, red, orange, yellow, green, and blue can be used as a multiplier. Are we together? Violet can be used. Violet. Sorry, I just made a mistake. Violet can be used as multiplier. But gray color cannot be used as a multiplier as a multiplier band. Hello? Pay attention on this concept, because they really confuse. They really what? Confuse. Then the next color, that will be number 10, it's white. Say white. Who is white? Ask your neighbor, you white? So the white color, it can be used in the band or in the band of the significant digits only. The white color cannot be used to show tolerance. The white color cannot be used for the gray color. It's tolerance. Gray can be used to show tolerance, and tolerance is 0.05%. Are we together? But white cannot be used in multiplier band, and the white cannot be used in tolerance. Check your neighbor. So then we go for other colors. So these are the common. The next 3 colors, we call them, the next 2 colors, we call them common colors for tolerance. Are we together? Common colors that to show what is tolerance. These colors, the first one, we call it what? Gold. Say gold. Gold, Ruben, stop writing. The second one is silver. Do you like silver? Ask your neighbor, between gold and silver, which do you like most? Then ask your neighbor, if I go in the ornament shop and I want to buy a chain for you, should I buy a gold chain or a silver chain to give you as a gift? And a special what? Easter gift. Ask your neighbor. So gold and silver cannot be used in the significant. Gold and silver cannot be used in the band of the significant 30 digits. But gold and silver color can be used in the band of the multiplier. And the year value is 0.0. This is 0.1, and this is what? 0.01. Do you see the trick? But gold and silver can be, I told you that these are the OT, these are colors, special colors for the tolerance, right? So if the goldy color is used to show the tolerance, its tolerance is plus or minus 5%. Most commercial electronics resistors or commercial resistors, they use goldy as a tolerance. They use goldy color to show the tolerance, right? Then for the silver, it's plus or minus 10%. But sometimes we can find some resistors which have only 3 bands. 3 bands. The 2 band for significant digit, 1 band for multiplier. There is no band for what? Tolerance. So it means that sometimes the band of tolerance is none, does not have color. Say none. Say none. So if it is none, there's no band for color, then you find that this is plus or minus 20%. Band, there's no color for tolerance. Listen, students, I know that when you've been learning electronics, you covered some information, few information that I've showed there. Do you know what you have covered? You have covered the 4 color band resistor, but you have never dealt with the 5 color bands and 6 what? Color bands. I know you somehow. But when you come for this table, you just see crammed that all of these 10 colors, they just see, use the insignificant digit section band and the multiplier. But they are not used to show what? Tolerance. And that's why that if we given us a resistor, and as you don't see the goldy color in one end, or the silver color in one end, you say that this resistor does not have tolerance. I don't know, where should I start to count? Are we together? So from this concept, your mind about color coding and about the property of resistors, about the mind of the manufacturers should be broadened. Why should it be broadened? Because if you don't find the silver color in the resistor or goldy color in the resistor, you should not worry. You have to say, okay, which color is at the end? The color is at the end is green. Okay, its tolerance is 0.5. Are we together? Then I don't see goldy. And maybe you go for the practical. Then maybe the teacher asks you, okay, determine the resistance by using color coding. And then your classmates say, this resistor does not have gold and silver. Where should he count to? Where should he start to count? And then you tell, okay, my dear, you have to broaden your knowledge of color coding. One of the color at the end, brown. Because for those resistors which are using brown intolerance and red, they have to make sure that this brown color which has been used, they make sure that they don't use any color that has a tolerance. Listen, the color for the band for tolerance is always at the end of the resistor. Are we together? The color, the band that shows tolerance is always at one end of 40 resistor. So the question comes in my mind, okay, we can use this color for tolerance and this one. How can I differentiate that with others? If you use brown to show the tolerance, right? On one side of the resistor. On the other side, we don't use brown, we don't use red, we don't use green, we don't use blue, we don't use violet, we don't use gray. We may either use white or yellow or orange in order to avoid confusion in your mind. I think that this I have to clarify. And then end, because I think that students that have been overflooded with material. Listen. Let me clarify this one and then we have to end the class. Listen. Suppose that this is the resistor. Okay, let me just teach you the detail. Go in detail. This is the resistor. It has 4 bands. Let us start the fundamental 4 bands. Right? According to what we have learned, either this band show tolerance or this band show tolerance. One of them. Do you agree with me? So the band for the tolerance should be either on the left-hand side of the resistor or right-hand side of the resistor. It means it should be at one end of the resistor. That's number one. Right? Right? Yes. So if this show tolerance, then this and this one show what? Significant digit. And this one show what? Multiplier. Are we together? So if a resistor has been made by using gold and silver as a tolerance, there's no problem because gold and silver are different colors. Okay? So if it has been used in gold, so you can find that the color at this end is either goldy or at this end is either gold. Hello? So goldy color, you can find that the gold and silver are not used in significant digit. Right? Right? That's why it's very simple for students to compute or to calculate the resistance of the resistor by using what? The resistance of the resistor which has a silver and gold color intolerance. Why? Because they know this is exclusive in what? In significant digit. Are we together? Are we together? So if that's the case, so remember this is table what? You have to write this is table 1. So the title is what? The table of color band of what? Resistor. So it's okay if you are using gold and silver. Intolerance is fine, right? The challenge is if you don't see goldy on right hand side of the resistor and or silver on the gold on the right hand side or left hand side of the resistor, or you don't see silver on right hand side or left hand side of what? Resistor. You just see other what? Colors. So let me clarify. So remember that not all the 10 colors can be used in tolerance. Do you agree? Black cannot be used in tolerance, to show tolerance, right? Yellow cannot be used to show tolerance. Then we have what? Orange cannot be used to show what? Tolerance. So for any resistor that uses brown or red or green or blue or violet or gray as a color that shows tolerance. If this one, for instance, on this side, it's brown, right? At one end it's brown, right? Or at this end, the color should either be orange. The color, the first band, should either be orange or yellow or what? White, right? Yes, one of the color among the 3 colors. Are we together? So from there we say, this is brown. Okay, this brown shows tolerance. And then this is orange. Okay, orange shows the first significant digit. This is yellow. This yellow shows the first significant digit. And then this is white. This shows what the first significant digit. Are we together? But sometimes you can find, I remember now, the Holy Spirit is reminding me, sometimes you can find some resistors, and I have them, which have a color band selection 1, 2, 3, 4. You see? Here it's brown, and here it's brown. Right? So one brown is for what? Significant digit. Another brown is for what? Tolerance. That's all. Wow. Should I repeat? I said, some of the resistors, you can find that they have brown in one end and brown color in another end. Or they have red in one end and red in another end. Or they have green in one hand and green in another hand. And then, or they can have blue on one hand or blue on the other hand. Or they can have violet on one hand and another hand. So for that case, how can you calculate the resistance by using the color coding? It's simple. So remember that brown, red, green, blue, violet, gray can be used to show what? Tolerance. So one color will show what? Tolerance band. The other ones will show significant digit. Class, are we together? Remember also brown can be used in between here. As we say, brown can be used as a second significant digit. Brown can be used as a multiplier. But there's no any resistor that have brown, brown, brown. I just give you some examples. Are we together? Is it clear? And then let me explain about this none. Say none. We wrote none. It means that none, we say that some resistors has 3 bands. So this none is used in case that you count a resistor which have only 3 bands. 1, 2. So this we call it, good luck, listen. This is 3 band. So if it's 3 bands, listen. What? The first band show what is significant digit. The second band show what is significant digit. The third band show what is multiplier. Then the band, the first band, which is tolerance, is not there. Right? So for this resistor, it's tolerance. Tolerance of this resistor. Tolerance of this resistor is equal to what? Plus or minus 20%. So today you know how to deal with tolerance of 3-band resistor, 4-band resistor, 5-band resistor, and 6-band resistors. Hello? Class, are we together? Are we together? So make sure that you go and review this concept. I told you that if you do practice, Jacqueline, if you do practice of using color code, one of the testing questions in interview, especially practical electronics interview, when you go for the interview, they will give you different resistors and they'll ask you, and they don't give you the ohmmeter or multimeter. They ask you that compute the resistance of those resistors. And they give you a very short time. So how can you pass that interview? It's very simple. If you do practice, daily practice, these colors will be in your mind. So whenever you check, and then, okay, this is a tolerance, so I have to come from here quickly. You just compute in your mind. Then you say, this is 47 ohm resistor. This is 1 kilo ohm resistor. This is 4.7 kilo ohm resistor. This is 470 ohm resistor. So it's come like you are friend, just like your name. What's your name? My name is Olenjolai. You don't need much time to think, right? Why? Because I've mentioned Olenjolai. Are we together? So that's the assignment that I'm leaving it to you, because this is the end of this workshop. So the assignment of the homework is this one. The question is master and the practice. The concept of what? The concept of resistor color coding. Resistor color what? You have a question? I have answered that question. Okay. One of the students is asking, what if a resistor, it has maybe for this side, brown, and for this side, it has green. Which one are you going to consider the tolerance? That is your question. I've answered you that. When these manufacturers make, they avoid confusion. So in case they use different colors, I told you that. If they use brown to show what? To show tolerance on this side. On this side, they have to use 8 of this color. Are we together? Yak, is it clear? I say, if we use brown, we cannot use brown here and also use red here. Are we together? You cannot find a resistor like that. That is just a brown color and red here. So if it's brown, here you'll find N of this color. If the color used for the tolerance is red, then you can find 8 of this color. If the color used to show the tolerance is green, then you can find 8 of this 3 color. Are we together? Are we together? Okay, I think that let us finish this workshop with the part of how we can calculate, because I want to leave the homework for you. But I will break this video. So this will be workshop. Listen, in this workshop you have workshop 4.5A and workshop 4.5B. The same workshop, but I will break in order to reduce because you cannot watch the workshop, the single video of more than 2 hours and remain active. Are we together? Yeah, so that's what just I want to tell you. So is this concept clear? Huh? Can I clean the blackboard? So then now let us end this workshop by learning the formula of calculating resistance of fixed resistor, fixed resistors by using color coding. By using color coding. This is the formula. Look. Stop. This is the formula. For you to understand this formula, I think that let us start with this one. 4-band resistors. Stop writing. So for the 4-band resistors, we can compute resistance. You can compute the resistance. Resistance. Yes, look. How many significant digits do you have for 4-band? How many significant digits, how many bands we have that indicates the significant digits for 4-band? 2. So it means that we'll have digit 1. Then we don't add, we don't minus, we don't multiply. We have also to write digit 2. Okay? Then next what? We have to multiply. That's what multiply. Say multiply. We have to multiply with what? Multiply. So we have to multiply with what? Multiply. So look. So if that's the case, you say that resistance, in other words, is equal to digit 1. Then next we write digit 2, the second digit. Okay? Then we multiply by 10. 10 power n. Where n stands for what? N stands for multiplier color. Number of specific. N stands for digit of color used in multiply. Okay? So it means that resistance of the resistor is equal to first digit, second digit, times 10 power n. Then you can use comma to show the tolerance. For instance, you can use comma and then write the tolerance. So now, for that case, we say that the overall formula now can be resistance is equal to what? First digit, let me just use this way. And then you have what is second digit. Then you have what? Multiply by what? 10 power n. Then we have what? We have to write tolerance. So this is the formula that can help us to compute it. To compute resistance by using color coding. Remember that where n is equal to what? Digit of color used where? In multiplier band. Is it clear? Class, is it clear? That is for the what? For the 4-band resistor. Can I clean the same? I can't, yeah? I have to clean here. Those are the students. Then B for the 5 band. 5 bands resistance. How do we calculate? Stop writing. Let us write together. What the formula to calculate resistance? It will be what? Is equal to what? First digit. Next is what? Second digit. Then third digit. Very good. Then multiply by what? Multiply. Then what? Comma what? Tolerance. So if that's the case, say that here we have first digit, then you have second digit, then you have third digit. Don't multiply the digits. Then multiply by what? 10 power n, comma what? Tolerance. So this is the formula for what? For resistance. Students like to see something like that, to memorize. Then let us finish for the 6 band. For the 6 band resistor, the formula still the same with 5 bands. Right? Right? Because the 6 band is just it shows what? The temperature coefficient. So in 6 band, we have the first 3 bands are for significant digits. The 4th one for multiplier. The 5th tolerance. And the 6th temperature coefficient. Are we together? So the formula still what? The same. So let me give you 2 examples and then we end this workshop. B. Because you have workshop A and workshop B. Do you understand what am I teaching you? Do you understand? Eh? Very good. So let us example 1. Calculate you can write resistance of a resistor with a resistor that has the following color band. Yellow. So listen, I think there's the one thing which I have to explain to you. Listen. Ruben, can you come there? Okay, so my dear students, I want to teach you one trick that most students get challenged. Now you understand about the color band for significant digit, the color band for multiplier, the color band for tolerance, and the color band for the temperature coefficient in case of the 6 band. Right now I want you to answer the question that you might be asking yourself, because the resistor it is 2-terminal. How can you align the resistor in order for you to just to check the colors and calculate the resistance by using the color coding? That's a good question. I can align this resistor in this way, or I can align this resistor in this way. So you just have 2 alternative ways, whether in this way or whether in this way. So if in this way, this is the left-hand side and this is the right-hand side. If I align this way, this will be the left-hand side, this is the right-hand side. So one thing what should be the point? The point is, whenever you be given a fixed linear resistor, you have to identify the tolerance band. For instance, this is the tolerance band, this is silver. So once you identify the tolerance band, you have to make sure that the tolerance band align on your right hand side. Right? Remember, the tolerance band can be a goldy, can be silver, can be brown, can be what? Can be ready, etc., etc., etc. Are we together? So if that the case, for instance, for this one, this is the tolerance band, and these other three are not the tolerance band. So then you can count that this is the first significant digit, second, and this is the what? Multiplier. So for any fixed linear resistor which will be given, identify the tolerance band first. Once you identify, you have to make sure that tolerance band should be on your right hand side. Are we together? That's the concept. Band is ready, and the first band, not the first band, is gold. So calculate the resistance of the resistor, of the given resistor, of a given resistor that has the following color bands. First of all, how many color bands do you have there? 4. So this is 4 color band resistor, right? The first color band shows what? A significant digits. So solution. Solution, we say that. So the first color bands significant. This significant. This shows what? This shows what? Tolerance. Well, so if that's the case, the first step, we have to say that what? Recall. Recall what? The formula. The formula of what? The formula of calculating what? Calculating resistance by using what? Color code. So we say that resistance of that resistor is equal to what? First digit. Pardon? Second digit. Then we have what? Multiplied by multiplier. 10 power n. Then we have what? Tolerance. Separating, subdrawing. You can draw also. Right? You can draw because we like drawings in engineering. So then resistance is equal to what? First digit. What the color? Yellow. Its digit is what? Refer the table. Refer table 1. 4. Then what the color of the second band? Violet. What is digit? 7. So you write 7. Then we have what? Multiplication sign. We have what? 10. 10 power n. N it's what? The color for the multiplier, which is what? Red. Its digit is what? 2. So it will be 10 power 2. But what? Oh. Then comma. The color for the tolerance is what? Gold. What the tolerance for the gold? Plus or minus 5%. So resistance of the given resistor is equal to what? 4700 ohm, which is equal to 4.7 kilo ohm. And this is how we can calculate resistance of the resistor theoretically. For simulation, I will teach you how we can use ohmmeter to measure. Because the resistors we have in simulation, most of them, they don't have color bands, except for some other offline and online simulation software. But for Proteus, doesn't have a color band. Right? For practical, we'll be using the ohmmeter to measure, and we'll measure. And if we measure the resistance of that resistor, we will never get 4.7 kilo ohm. Why? Because of the tolerance. We'll have a measured value. At the end of this program, or at the end of this topic, we'll be having 3 tables. Theoretical table of resistor, simulation, practical. Right? That's the point where we are heading. So let me do the second example and give you the simple way to remember the color coding of resistor. Then we'll end our workshop. But I will leave the homework for you. Example 2. Example 2. Calculate what? The resistance. Calculate the resistance of resistor X, whose color band is brown, black, brown, gold. Solution. Separating. The first step. Recall what? Formula. I have formula. Resistance is equal to what? First digit. This is 4 band, 5 band, 6 band. Pardon? 4 band. Then said what? There's no said. Multiply by what? 10 power n of our, then we have what? Comma tolerance. Resistance of resistor X is equal to what? First, I have brown, it's digit 1. Black, it's digit, hello, 0. Multiply 10. Brown is digit, multiply is what? It's multiply is 1. N it's 1, but multiply it is 10. Right? Then gold, tolerance is what? Plus or minus what? 5%. So you say that, therefore, resistance of resistor what? X is equal to what? 100 ohm. With the tolerance of 40 plus or minus 5% So I believe from now onwards you can calculate what? The resistance of 4-band resistor, 3-band, 5-band resistor, even 3-band resistor and 6-band resistor. But also you can identify what? The tolerance. We don't talk about what, because this program is fundamental, we don't talk about what? Temperature coefficient. Are we together? So finally, let us end this class in this way. How many colors did I introduce to you? 13 colors, right? But 7 colors among those 13 colors, we can remember them by referring the technique that we have taught you in the topic of color, which is being taught in physics form 4. Are we together? How many colors do we have in the white spectrum? 7, right? And those 7 colors, we just abbreviate them as what? Roji what? Roji beef. Say Roji beef. Roji beef. Say Roji beef. These are the 7 spectrums of the white color. White light, right? 7 colors of white light, or 7 bands, or 7 spectrums of white light, right? R standing for what? Red. Those days when Fatuma was younger, was young, very young. This is standing for what? Red. This one, orange. This one, yellow. This one, green. This one, indigo. This one, blue. This one, 1, 2, 3, 4, 5, 6. This is not there. This one, violet. So listen, the trick. So the indigo, it's only one missing. You have to remove it. Are we together? Then you have to add 2 colors on left hand side, which is what? Black and what? Brown. So this is what? 0, 1, 2, 3, 4, 5, 6, 7. Wonderful. Then you have to add some other 2 colors on the right hand side. What are those colors? Gray and what? White. What the digits for gray? 8. What the digits for this one white? 9. Then you have all the 10 colors of what? Of the color band. Fatuma, did you understand or should I repeat? You have understood? Sure. Yes. If you didn't understand, you can listen several times this part until you understand. So there's no need for you to have a big exercise book or a paper that's showing the colors. You can just memorize them in this way. Remember Roji beef, add 2 colors on the left hand side and 2 colors on the right hand. Then you have 10 colors. But remember to remove indigo. Right? So if that's the case, you have any question about what you've covered? This has been a long workshop. But we thank God because this is all, this is the end of the theories of resistors for the fundamental level. So I'm very glad to announce that the theory we have covered about resistor, it's enough. You can carry it on, review it several times, and make sure that you practice as long as you can. Still have the simulation part and the practical part of 40 of resistor. I did not discuss about the ohmmeter. We'll discuss it later. It's not a great deal actual. We can just discuss it within a short time and then see it goes well. So the homework, I want to tell you that I will give you find a number of resistors. The homework, find a number of resistors and calculate their resistance by using color coding. Because color coding is the theoretical. Using ohmmeter is practical. It's measurement, right? But color coding is theoretical. So later you will compare the measured, the theoretical value and the measured what? Value. So this is the end of workshop 4.5. I thank God. I would like to take this opportunity to thank all the physical students, and also I would like to take this opportunity to thank all the online students. I would like to congratulate. This workshop has been long, but I gave you a promise. I will break down into 2 parts, workshop 4.5A and workshop 4.5B. Are you together? So when you finish workshop 4.5A, you have to go for workshop 4.5B. Make sure that you watch this video several times because I've taught you a lot of information within a short time. But the good thing that we've recorded and keep the contents, you can review several times until all of those concepts being written in your mind. So I think it is clear. So I would like to take this opportunity to welcome you in the next workshop, 4.6, where we'll be discussing about the simulation part of the resistor and some other simulation and some other what you call them and other practical part of the resistor. So this is Olenjolai. I thank God who have given me strength, understanding, knowledge, just the skills on teaching you about resistor. I don't know everything about resistor. This is just a small portion of what I know about resistor, but I have the responsibility to teach others. So then remember to register yourself into our official YouTube channel by clicking the buttons of subscribe so you can get notification whenever we publish a new video. Remember that in those channels that you are watching, online Diploma Polytechnics of Tanzania and also online Bachelor Polytechnics of Tanzania will be adding at least 1 video in a week. So make sure that you subscribe and make sure that you use your internet effectively for the learning resources. But again, in case that you need electronics components, resistors, a number of resistors, maybe you need different values of resistors of the 4 color bands, 5 color bands, or 6 color band. Please don't hesitate to contact me through this number 0759 745331. I will send it to you and with a very affordable price. So if that's the case, thank you very much and welcome into the workshop 4.6. But if you have a question, should not hesitate to ask in the comment section. Share this information to other students who are pursuing bachelor in electronics engineering, or bachelor in telecommunication engineering, or bachelor in biomedical engineering, or bachelor in mechatronics engineering, or bachelor in computer engineering, or bachelor in biomedical engineering, or bachelor, even just sometimes some of the institutions also they are learning some electronics skills, because this is the fundamental issues. So, but also for ordinary diploma, share the contents to all those groups of the students, even the renewable energy students. So if that's the case, may God bless you. I love you so much, and let me meet you in the next workshop. Bye bye, be blessed.